Here's the Cauchy's integral formula. We have two of them done, right? Z minus a in the denominator and z minus a squared. That was all done just using the linear approximation. So you have to go to the next level. One thing we have here is at all the level of this thing exists. Not a, that's more importantly, these are all analytic, right? For all n, no matter what the analytic function is. So I think it's convenient to do this statement to inductively to the n, just like the other level. So we have base case is done, right? So it's proof of nth derivative at a is equal to n factorial and 2 pi I, right? And this integral c that contains, importantly, contains the singularity down inside this region enclosed by c. And what is the power? I think it's 1 more n plus 1. And there's f of z, then dz. We have some base cases established already, right? We proved that. So base case is done. So we assume, I think, this level there. Assume the statement for some n, but this statement is not limited to particular n. So I think the key thing to note in here for some n, and for all analytic function. F, G, let's say. So think about the structure of the induction. You fix n, and it doesn't matter which G you replace it here, and that's going to be true. The statement is true for all n. If you think about Cauchy's formula for z minus a and z minus a squared, this is true for all f analytic functions. So there's all for function partial in there. What is fixed here is n, and we want to show, we want to consider fn plus 1 of a to that part. So how much you go down this level in here? This is nth derivative. You're taking it all the way back to original function. We're going to apply that right here to that one, because now as n plus 1 level, we cannot apply the Cauchy's integral formula directly, but think about this one as like this. F prime of, let's say, probably this is easier because it could be confusing. So the logic could be confusing in here. So I'm going to call that g of z of f prime of z. Okay? So this is a trick to kind of go down to one level of the derivative. We're going to apply this one in here, this statement, I'm going to call that star, to gz, right? That's allowed. This is for some fixed n, we can apply any function, any analytic function. Good. So let's do that. G of nth derivative of a, is that right? Is equal to n factorial divided by 2 pi I from c to g of z divided by z minus a to the n plus 1 factorial dz. That we have it here. Right? So, any question about why this induction looks okay? We still have n, and we're just changing the function in the background, and which is our assumption. That's the base case we're going for. So next bit is going back to this one like this, 2 pi I and C, and changing this one. What is the G of Z? Is F prime. F prime of Z. And Z minus A to the n plus 1 and dz. And our goal is getting this one down to f of z divided by something. So can we just integrate just that part, f of z? If you integrate f prime of z, then you get f of z, right? What technique is it called? Just integrating just one part. I'm going to call the other one like this, negative n plus 1, right? That's how you write it, the other one. What technique is that? I'm going to keep that as a coefficient in 2 pi I and integrate just that part, f of z. And you leave that, the other guy like that, right? And minus integrating for the same thing. So this is not indefinite integral. So what should I put in here after you integrate that? Right, curves. So starting from z0 to z0, whatever the fixed point you see in there. You see that? So these are analytic around that thing. It's a, it's a 0. So what about the other one? F prime of z, and derivative of the remaining phase, derivative of this one, right? So if you take that one down, that's going to be negative n plus 1, right? And you subtract 1, then it's going to be n plus 2. Is that right? So z minus a n plus 2. That's dz. Make sense? Close the parenthesis. Let's see what happened. This antiderivative evaluated around this closed curve. And that can be 0, right? Can be 0. And this negative becomes plus. There's n plus 1 from evaluating in f of z. Z minus a raised to the next power dz, right? So if you put them together, now it picks up n plus 1 factorial 2 pi I and f of z divided by z minus a n plus 2 dz. Okay? But what's the left-hand side? Left-hand side is that differentiating g n time is actually differentiating f n plus 1 times. Right? So that's going to be n plus 1 differentiation is equal to that guy there. Make sense? So I'm going to put it down there like this.